In this video session, we are going to see a problem on real numbers for the 10th standard CBSE Mathematics. The problem definition is 3 tankers contain 403 liters, 434 liters, and 465 liters of diesel. Find the maximum capacity of a container that can measure the diesel of each container in exact liters. It is just a problem on dividing diesel from 3 tankers, and by means of a container that will exactly, in exact liters, it will divide among the 3 diesel tankers. Okay, let us see now the problem definition again. 3 tankers contain 403 liters. So one contains 403 liters. That's capacity of the tanker. The second one, 434 liters, and the third one, 465 liters of diesel. We have to find the maximum capacity of a container, one container that can divide it, then measure the diesel of each tanker in exact liters. There should not be a fraction there. So let's go to the solution. Before that, we'll just see the thinking process with the explanation. 3 tankers. If you want to measure diesel from each tanker using containers of equal maximum capacity, such that each container holds an exact number of liters from each container, each tanker. So here, the greatest capacity in liters of a container that can exactly measure the diesel from all the 3 tankers. This means we need to find the HCF, the highest common factor, that will exactly divide these 3 capacities, 403, 434, and 465. So we need to find a number that is nothing but the highest common factor, because it's given that it's the greatest capacity, the maximum capacity of the container, which can exactly measure the diesel from all 3 tankers. Let's go to the solution. The first step is to find the HCF of the 3 numbers. Each number, prime factorization. We have taken 403 first. Is odd. So try to divide by 3, then by 7. It doesn't divide exactly by these 3 prime numbers. So the next option is that we have to go to the, of course, we didn't try that 5 there because this number doesn't end in 5. So what we do is, if the number is odd, the first step is to divide by 3. If it is not divisible by 3, then we go to 5, but 5 is, this 403, 3 is not ending in 5. So it is not divisible by 5. So we go to 7. It is also not divisible by 7. So we go on to 11. 11 is also not, it is not also divisible by 11. So the next prime number is 13. And when we try to divide 403 by 13, is it exactly divisible by 13? And we get the quotient as 31. Further division is not possible because both are prime now. 31 is also a prime number. So these are the 2 prime factors of 403. 403 is equal to 13 into 31. See, there is a palindromic number here. 13 and 31 are sort of an interchange. If you just interchange 13 and then the digits, it becomes 31 here. A keen observation here. Next, since 434, the next number is 434, is even, we try dividing it by 2. So it will be divisible by 2 and we get 217, 217. Then we divide by 7. We know that it is exactly divisible by 7 and we get 31, which is also prime. So we get 3 prime numbers. 434 is equal to 2 into 7 into 31. All are prime. Next, we move on to 465. It ends in 5. So we try to divide it by 5 and then we get 93, which is the quotient, which is further prime factorized as 3 and 31. So you will be getting 465 is equal to 3 into 5 into 31. We always better to arrange the prime factors in the ascending order of their values. See, 3 into 5 into 31. All are prime here. Now we find that the HCF of these 3 numbers should be a common factor for all the 3 numbers. Common factor, factor that is prime factor that is common to all the 3 numbers, which is obviously 31 here. The only prime factor common to all the 3 numbers is 31. Hence, the HCF of 403, 434, and 465 is equal to 31. The maximum capacity of the containers is 31 liters. We arrive at this answer. Suppose we want to find out the number of such containers that 31 liters each is required to distribute the diesel in the 3 tankers. How many containers does the 403 liter tanker require? Then we must divide the capacity of each tanker by 31 separately. And we get like this. We get a picture like this. In this picture, we see the 3 tankers are being divided by 31. The capacities of each of these 3 tankers is being divided by 31. By dividing by 31, the first one you'll get a 13. Obviously, because it is there in the prime factorization itself, we have done is 13 into 31. So 13 should come there. 13 containers are required to fill the tanker, which has the capacity 403 liters. And similarly, 14 containers are required to fill the 434 liter capacity tanker. And finally, 15 containers are required to fill the 465 liters tanker. So these, when you add these 3 numbers, you will get the total number of containers times you have to fill these 3 in exact liters of 31. So we get the solution here. Hope you understood the solution. And that's the solution to this problem.